5 minutes. Okay, so it looks like almost everybody is finished, so let's go ahead and dive in. All of these examples are great, but definitely a big shout out to Regina. Regina really loved the way you put this together and combined the knowledge of, she took the knowledge of what we'd already done in terms of displaying images and JPEGs in a callback function, and then combining it with the tabs. So this is excellent and definitely makes me want to go out and get a burger. Thanks for that. And then all of the other ones are also excellent and definitely put into practice exactly what I was hoping for, which was really just to kind of kick the tires on this, do some cosmetic changes to it, see if you could put together a 3 or multi-tab app similar to the one that I'd slacked out. So this is great. Let's take a look at the code. Let me do a little bit of talking and then open it up to your questions. This example, it's a bit larger here. So this example does something that's very common in Python, but we haven't seen a whole lot up until now, which is to have a project that's so large that it spills across multiple Python scripts or files. Up until now, everything we've done has been self-contained in a single app.py. But in fact, in a real-world project, if you were to do that, you would have extremely messy code that would be 300, 500, 1,000 lines long, all in the same script. And that can get pretty complicated to navigate, where you're constantly scrolling up and down and up and down trying to figure out what's going on. A much cleaner way to organize your code is to break it out into 3 or 4 or 5 major chunks and have each one of those chunks be its own Python script, its own .py file, and then have all of these orchestrated by a single primary file that imports the others. And frequently this is called main.py or index.py, but because we'll be deploying to Heroku, we're going to go with their default app.py as the name of our primary file. And you'll see that in app.py we have our typical imports, dash core components, plotly, and then we have these three interesting lines, 6 through 8, where we are actually importing our own scripts the same way we import Python libraries. Here it says from tabs, import tab 1, 2, and 3. In this case, tabs is a directory over here on the left, a little bit small. But if you open up the tabs directory, you can see that the Python scripts are all living inside of it. And the reason that this code works is because app.py is at a higher level than the others. It's at a parallel level to the directory and one step above the contents of the directory. So that's how from tabs import tab 1 works. And you don't actually have to write tab1.py. It gets the gist of that. There is, by the way, my example doesn't do this, but you can also say from tab 1 import my function, and this is also frequently seen, where you, from a script that is at the same level as your main or your app.py, you simply import a single function, or even all functions with a star. But this one doesn't do that. It is importing the entire script. And then where does that get called? Well, it gets called a little further down in the first callback. So we have a callback here. This callback is callback for the tabs. And we see that the input is the tabs component that was defined higher. And the output is simply a standard HTML div. But what it's outputting is the variable tab1 layout that's defined in the script tab1.py that we imported up at the top. So if we toggle over to tab1.py and we take a look at what that looks like, it has a variable called tab1 layout, which consists of a rather lengthy HTML div. It's all of the display contents that we would like our final rendering to put out there. It does not include any callbacks. What it does include is it includes a drop-down input div, and then a blank div here. Notice that children is equal to blank, named page 1 content. And that's where the content is going to get displayed. So going back over to app.py, and that refers to the second callback. The second callback, page 1 content, is displaying the contents of this function. You have to selected so-and-so. So page 1 dropdown exists in the file tab1.py, and page 1 content also exists in the Python file tab1.py, but the callback and function that links the two of them does not. It lives in the primary file app.py. The reason for this is a bit murky to me, and I understand that there are some workarounds to it. I have a friend who says that he gets his to work smoothly, but this is what I have learned about it. Plotly-forums. By the way, the Plotly-forum, if you haven't discovered it yet, is a tremendous resource for all things Dash related and structuring a multi-page app. So I had a comment here a while back where I pointed out that I found it necessary to include all of the callbacks in the primary app.py. And that if I didn't do that, if I put the callbacks into the individual tab pages, they did not fire correctly. And I got feedback from Chris Parham and a few others in the community that at the time of my posting, which was a year ago, September 18, that in fact that was the case. Now, Plotly is a rapidly evolving library, and they may have actually found a way to work around this. But as of the time of a year ago, when I did the investigation into all of this, it was definitely necessary to have all of your callbacks in the highest level file. I'm going to give an example here. It's not too different from the one that you guys took a look at, maybe a little bit simpler. So it looks like everybody was able to get that to work, which is great to see. A few other things that are kind of chestnuts in here. First is the use of background color and font color in order to style that little footer at the bottom of the page. Again, you could do your styling with CSS, but for simple stuff like this, it's not hard to drop it right into the file itself. Notice that the style parameter comes immediately after, or frankly before, the class name parameter, but it must be outside the bracket contents of the div. What else is worth pointing out here? I guess the only other big thing is that we are looking at a new DCC component here. DCC tabs has a number of children, each of which is DCC tab without the S. So this is a new core component which we haven't been exposed to yet, and it has to be structured with tabs on the outside and tab singular on the inside as the children of tabs for this to work. And then it also has to be tied into a callback whose function is to return the different tab layouts as expected. Okay, so questions, thoughts, or observations about this example? What do you guys think? Yeah?
Is there a reason for the output and input they look like they're reversed? So I would put input first because it's...
Here.
Yeah.
At lines 50 and 51.
Can it work if you put input first or not?
So I've never tried it the other way around. It might. I always see it structured this way. Notice that input has to be in a list, which I think is the real identifier. But just for the sake of argument, let's find out what happens if we reverse them. Because that is actually a good question. So I'm pulling my inputs, dropping. I do it this way just because that's how I was taught to do it. But let's save and go here and Python app.py. And it is telling me, and this is too small to read, it's giving me an error message. So it looks like that, in fact, is not going to be kosher. Looks like here, incorrect type exception. The argument tabs example value must be of dash output. So yeah, it looks like that's going to be a no-go. Why they structure it that way, I don't know. Other things that you learned by tinkering with this one, or that you observed? Great. So again, this is it's a common way to structure not just a Plotly Dash app, but really any large-scale Python project, where you have, typically the way I've seen it is you have a lot of your functions in auxiliary scripts, so that the functions can end up getting quite long, and then you import all the functions into the main script and just call them there. That's a great way to organize it. And that way you don't, because functions can be defined anywhere, above, below, in the middle of your code, or in a secondary helper script. So to keep things clean, you define all your functions in one file, and then you have your, your primary script in the other file. And I guess I'll end with this. This information here, if name equals main, the reason why this always is in here, to the best of my knowledge, you can actually just have it like this, and it will work fine as well. The reason why, both in Plotly and in other Python files, it's customary to specify if name equals main is precisely because of the idea of importing one Python script into another. What this means is only run the server if the name of this Python script is equal to the system variable main, indicating what is the primary Python script that is currently being run. If you are importing a script in another script, its name is not main. Its name is secondary or something like that. I forget what it is. And as a result, if you drop this into your auxiliary code, it will prevent it from firing accidentally, except when it's being imported. That is, it will prevent it from firing accidentally when it is being imported. That's what I meant to say. Okay, great. Well, I think that's a good example. I'd love to see it if you start thinking about how to incorporate tabs into your final project, because it definitely, the advantage of tabs is that it allows you to really maximize on real estate. If you want your app or your web page to do a lot of stuff, but you don't have tabs, you have to scroll vertically a very great distance. And here's an example of one that I built that actually does that and doesn't look very good. It would be I thought I had it at my fingertips. But anyway, you guys get the idea. This is one I built a while back that just you have to scroll vertically up and down a great deal in order to see all the output. It's much cleaner just to have the tabs and toggle back and forth so that the user doesn't have to use the side scroll bars at all.
So can you set up different input types for that as well, like drop down, tab 1, tab 2, tab 3?
A different input other than tabs?
Yeah, so effectively, it would be a drop down menu, for instance, where you can switch between seeing with tab 1, tab 2, or tab 3.
Yes, you can definitely do that with the simple with the drop down that we're already familiar with, but that's obviously something different from tabs. Well, here's a quick one that does exactly what you're talking about, which was Tamic on Heroku. Yeah, here we go. This is an example of what you're talking about. This is going to take a second to load. Never mind. I'm not going to wait for it. Yes, you can definitely do that. And there's a couple of other nice options that you can find in the Plotly Dash documentation that give you alternatives to using tabs.
One more question.
Yeah, go for it.
Is it, so if you have a auxiliary script that includes functions, is it commonly called that index.py?
No, index.py is what the primary one is frequently referred to, either as main.py or index.py. I don't know why that is. I always thought index is where you would look stuff up,
Right.
but it's just that's not the way I've seen it organized when I've seen other people's code.
Okay.
Names for the helper script. Trying to think what I have seen. Helper.py is a frequent one. Resources.py, I don't know. I don't know that I can say I'm familiar with a kind of a standard name for that.
Okay. Thanks.
Yeah, definitely. Okay, great. So let's go ahead and close that up and turn to Jupyter Notebook. Tonight we are continuing with Repo 7, which is the introduction to pandas. And please go ahead and get your Jupyter Notebook running in Repo 7. And let me know here when you are ready to go under General. Repo 7 open in Jupyter Notebook. All right, so I'm going to dive into code. And this time we'll be doing number 2, Intro to Pandas. Again, apologies, I do not have a cleaned version of the solution code. The solution code simply has all the answers in it. But as we did on last week, Thursday of last week, we'll be doing this same code, kind of cherry picking certain cells in a new notebook. So if you'd like to have them both open for reference, go ahead and start a new file. And we'll call this O2 class notes. Make it large. Introduction to pandas. All right, so we want to import pandas as PD. And for good measure, import numpy as np. Import matplotlib.pyplot as pl2. And %sign matplotlib inline. Matplotlib is one that we'll see a little bit more in an upcoming lesson, but it's the graphing library that is frequently used together with pandas in order to display bar charts and the pie charts and that kind of stuff. It's a predecessor to Plotly Dash. It only generates static images, but it's nice for Jupyter notebooks.
What is that matplotlib?
This is a line of code that will display matplotlib images inside the Jupyter notebook. If you don't do this, when you try and display the image, it'll show up as a static image, but outside of the Jupyter notebook. Okay, and we also want to do a couple of other imports. Import OS and from pathlib import path. And these imports, these are for navigating your system and finding the data. Okay, so just as we saw last time, where are we? We are in, I'm going to call a variable called home is path.current working directory, and then print home. And that's the directory where my Jupyter notebook is currently running. Home.parent is one level above that. One level above. And data directory is going to be home path.joinPath home.parent data. Print data here. Make sure to add my comments. Where is the data folder? What's in it? os.list dir data directory will show the list of all those files that we saw last Thursday that are in our data directory. And define a path to one data file. I'm going to call this one file path is equal to path.joinPath home.parent data, and it's a rather long name, production.product.csv. And print file path to see what it looks like. Okay, so this is the file that we want to call up. It's a CSV file that is built by Microsoft in order to simulate data from a company that sells sporting goods. It's packaged along with Microsoft SQL Server as part of their training program for learning SQL, but it also serves nicely as a data set for learning pandas, which is similar to SQL in a lot of ways. And it's a nice, clean, well-organized data set without too much missing data. So use pandas to read in the data file. I'm going to have a data set, I'm going to call it prod, which is short for production or products. Prod is equal to pandas read CSV file path and then call prod.head to see what it looks like. And I do this, and I get an error message. And the reason why is because even though it's indicated with a CSV in its name, CSV can actually be kind of a catch-all for a file that has almost any character delimitation going on, not just comma separated, but also, for example, tab separated. And down here at the bottom, we see that there's an error tokenizing the data. So we're going to fix that by indicating that not only do we want to read it in, but we also have to specify the separator as being equal to \t for tab. And now it reads in smoothly. Everybody get that okay? \t. But it's not separated by a comma, it's separated by a tab. Did that work for everyone? Does everyone see the data frame the same as I do up here on the screen? Yeah? Okay, cool.
Is there a way to, figure out the separator without knowing the file or seeing what to do, like investigating it?
I'm sure that there is a smart way to do it. I actually haven't done this enough to where I know what that is, but Stack Overflow is going to have a good solution for us, no doubt. Yeah. What I do, just for what it's worth, is I try the big ones, comma, I try pipe, and I try \t, and usually one of those three, 9 times out of 10, is going to work. I wonder what happens if we do put in pipe. Does that do anything? I'm curious while we're here. Oh, interestingly enough, it does read it in, but it puts it all into a single column. Okay, and keep in mind that head gives you the first 5 rows. If you put a number in here, it'll give you the number of rows you specified. Tail will give you the last 5 rows in the entire data set. And sample will give you a random sample of any rows from the entire data frame. So those are nice ways to just get a quick glance at what your data looks like. What is prod? Type prod indicates that the Python object is a data frame type object. And as a result, because it is a data frame object, it inherits all of the data frame properties, such as the following. Prod.shape. We saw that last time. What does this indicate? Exactly. What are the columns is prod.columns. You can do simply the length of prod will tell you the number of rows, so it's similar to shape. But you can also find out the length by printing the index. And what this tells me is that the index, that is to say the numbers on the far left-hand side of the table, start at 0, stop at 504, and increase in increments of 1. So just counting up to 504. You can actually assign almost any column to be the index, but that's the default index. New section. How to call individual columns. Okay, so we saw prod.columns, and we got the list of column names that are in the data set. But maybe we'd like to know what is the data type in each column. Prod dtypes. shows me that for each of those columns in prod, ID, name, product number, etc., some of them are pure numbers, so integer 64 digits. Some of them are strings, which is listed here as an object because it could be a combination of alphanumeric or just pure numbers. And some of them are floats because unlike integers, they have decimal places. Another common data type is date time, but there are no date time columns here. How to select an individual column. There are 3 ways to do this. The most common is prod, and here I'd like to let's call color is a good one to go. Prod.color will list all the colors in the data frame. And similar to an entire data set, I can use head on it or sample to call just kind of a few rows from across the entire data frame. So just as I did prod.sample, I can also sample an individual column. All right, this is the first way. Use brackets. And here, brackets indicate that you're calling a column, and then quote marks indicate the column name. And this is useful because if your column has spaces in it, for example, color and shape or something like that, the quote marks turn that into a string so that the spaces in the name don't make a huge difference. But if there are no spaces, there's another way to do it, which is prod.color.sample. And let's run that again because I don't want all nans. And this is basically giving me exactly the same results, but instead of putting the column name into brackets and parentheses, I can simply call it by using the dot method. So there's the bracket method and there's the dot method. This is shorter because, obviously if you're typing fast, it's fewer characters. But it has a number of problems, and it's actually not recommended as the way to do this. And from what I understand, they may actually remove it from an upcoming version of Pandas. First and foremost, if your column has spaces in it, suppose again our column is called column and shape, all of a sudden, that's no longer going to work. Up here, that worked fine. Column and shape, because it's inside of quotes, so that turns it into a string. But down here, I can't use the dot method if there are spaces in my column name. A second reason is because this does not allow you to call multiple columns. Suppose I want to call color and also, style. I can't do that here, but I can do it with the bracket method. And the third is because you also can't filter columns easily when they're written this way. So by and large, though this works, it's not recommended. The third way, most typing but best results, is this. Prod, double bracket, color, dot sample. And this is nice because it returns the object to me, but with formatting as if it were a little mini data frame. Let's see if I can get a few colors. There we go. So notice that the results are always the same. Index followed by color names, index followed by color names, and down here, index followed by color names. This one is the most typing because it has the double brackets and the quote mark, but it formats my results, and it also provides the column name at the top as if it were its own mini data set. And the reason this last one is most useful is because the third method allows me to select multiple columns as follows. Prod, bracket, bracket, quote, color, comma, style. I can't do that with any of the other methods, but this allows me to call multiple column. So what's another column name here? Let's call class. Color, style, and class. And that's a useful way to filter down the number of columns that you want to display. Now, I often get the question, why? Why is it written this way? Why do you use quotes? And above all, why do you use double brackets? I don't know that I have an easy answer for that. The quote marks is the easiest one to answer. You want your column names to be converted to strings because of that whole blank space issue that frequently occurs in column names. As far as the other brackets, I believe that the best explanation is to rethink what brackets mean. We've learned up until now that brackets mean a list in Python. But in pandas, brackets can also mean a filter applied to a data frame. So brackets mean filtering. And when you have a double bracket, then you are filtering on a list. The list is this. So I'm going to actually pull this out here. I'm going to call it list of columns is equal to this list, right? That's something we've seen all along. And now down here, using the filter method, I filter prod on list of columns, and that works nicely. And this demonstrates that first bracket indicates list, and second bracket indicates data frame filter. And as a demonstration of this, let's create another filter using brackets. Suppose that I only want to see blue products, right? I can filter my data frame as follows. Prod, brackets, and now in here, prod color is equal to blue. And now it will filter my entire data frame, but only to those instances where the colors are blue. So as I scroll down here, notice right where my pointer is located, everything is blue. And again, we could spill this out as a filter condition is equal to that, and then prod filtered on condition. And that'll give us the same results. So this shows that the first filter, the first set of brackets is a list, in this case a list with one element, and the second set of brackets indicates a condition. Questions or comments about that? Okay, let me pause there for a minute. Try two things. Let me keep this in the same cell. Call a subset of all columns. Create your own simple filter. Slack out the results as a screenshot. So I filtered on color is equal to blue. You try filtering on something else. Call me over if you've got a question or want some troubleshooting. Okay, and Eric has a nice combination of not just one but two variables in a single filter. Very nice. All right, so let's dig in a little deeper here. I know I've got a few more coming out. Max has got his. And what's nice about Max is that not only does he apply the filter, but then he limits the number of columns to be displayed after the filter has been applied. Okay, so what exactly is the filter doing? To better understand how the filter is working, go back a couple of steps to something we did earlier. Prod style dot head, or actually let's go with prod, something that actually got some values to it. Color, and maybe I'll call the first 10 of these. There we go. The first 10 colors are NaN. That stands for basically not a number, which is the pandas way of displaying a null value, which means the first 5 products, no color was indicated for them, so they are null values. Then 5, 6, and 7 are black, and 8 and 9 are silver. So of these, I can specify only show me the ones where this is black. So of those 10, which ones are black? And it gives me back the same 10 rows, but as a series of Booleans. False, 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 true, 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 false, false, right? Try toggling back and forth for the comparison on that. So here we see the actual values. And Here we see them as Booleans, false or true. And once you have a string of Booleans that is the length of whatever it is we want to display, you can simply apply that as a mask or as a filter. So we can say prod, and here's my condition. Prod color equal to black. Call that the head on that. And here we get the first 5 rows for which that condition is true. So basically, it's scanning each row for the true or false value on the filter, and then only displaying those rows where the filter is true. So that's kind of what it's doing in the background. And as, was it Eric or Max, when you guys did a double filter, it's not hard once you get the gist of kind of what's going on here. You simply put the first filter into parentheses, and then if you want a second filter, such as, oh, I don't know, we could say style is you, for example. Or class is large, that's a good one. Class is equal to large. And then you simply join them together with the ampersand. It looks like there are no cases where it's black and class is equal to large. Maybe if I'd chosen a different color, we'd get a few. I think class is large, medium, and small. Get out for a second. And I actually forgot what the true values are for class. But I get it, I digress. It was actually supposed to be introducing double filters a little bit later on anyway.
So can you specify a value that's null like NaN?
You can, yes. Null values are a little trickier though. You can't just say color equal to NaN because NaN isn't actually a value. In order to see the null values, you would have to say prod color dot is null, and then they'll give you trues and falses for the same. Bunch of null values, and then false indicates that it's not null. Or the opposite is null, and then its opposite is not null, and we'll do the same thing but in reverse. We have a whole repository on null values a little later on. That's just kind of a taste of that. And by the way, you can chain pandas methods. So dot head here is chained on top of the not null method. So it's showing the first 10 values which are not null, and their index numbers. And of course, we could have put that in as a filter. Turn that into a filter. Prod bracket, prod color not null, and then call the dot head on the outside of that. And we'll see the first 5 values rather, which are not null in terms of color. Another example of a filter that's not using color. So our condition is prod finished goods flag is equal to 1, and I want the first 3 values where that's true. Oh, I forgot I have the bracket in the wrong place. So I get a bunch of falses, but later on it's going to be true. And then if I want to throw that into a larger filter, I can say prod where that filter is true, and then call head on that. and that'll give me the first 5 where the finished goods flag is equal to 1. What this demonstrates, by the way, is that the white space doesn't actually make a great deal of difference. You can leave a fair amount of white space in most of these, and it'll still work just fine. Where you can't put it, I don't think, if you put it here, I'm pretty sure that breaks it. No, even there. Interesting. And finally, you can call a single column from filtered results, or even multiple columns. So I'm going to take the same filter, drop it here, and then specify that I want to only see list price and finished goods flag and color. And of that, I only want the first 5 rows, and that returns list price, finished goods, and color, but only for those instances where finished goods flag is equal to 1. Which is why if we look at the index numbers, they start at 209 because it's leaving out all of the previous ones. I believe the data set is actually sorted by this column. And if you wanted them in different order, you could have done that simply by rearranging the order in which you called them. Now list price will appear on the far right. Okay, the next section is calculate some simple summary stats on your data frame. But this is as good a time as any to break at 7:39, so come on back at 7:50 and we'll continue with this. Or earlier if everybody's back. 10 minutes. Yeah. Let me come on back. Let's put on a sweater. It's getting kind of cold in here.
So when I first looked at this, it's listing the breakfast on this, how to expect, even though it's not something, because I said that change the lunch, change it later. I'm trying to let the breakfast. Yeah. So what I did is I was trying to play with that and multiple tab files. Yeah, and the standard chain tab based on this is arrays and what I've used like that for tab arrays. Options. I have 0, 1, 2, so that oh sorry, okay, go slower.
Okay, so this is the DCC tab section. So each of the tab elements here is calling from your tabs list. Excellent. So it's calling that string as the label and the value 0, 1, and 2.
Which is what's showing up as breakfast, lunch, and dinner. So that part's where the values are 0, 1, and 2 as well. So that if you press the first tab, original times original breakfast, and then for 1, 2, and it's the same things.
It's very efficient.
So down here is where I'm putting this tab template. It's this function where I pass in the times from the value, so the values passed in.
Using indexing.
So I pass in the meal times and pass in the tab options. So when that comes in, it just looks like. So it basically sets the header and then it sets the option list. And that's working for
For lunch and dinner, not for
for
breakfast.
some reason it's not.
And breakfast loads on the initial load, not after selection.
Right. I can't figure out what that is.
And the callbacks inside of breakfast also load. Go back to your templates. When you're on the home page at breakfast, just drop it.
So go to breakfast.
things come to my mind about troubleshooting, and it could be something. One is that default value is specified as so it's possible that if correctly specified, and I haven't fully seen it, if correctly specified records is the default value, but in the code that's calling it, there's some typo that is making it fail there. So it succeeds as the default, but not inside the function. If you double check that, I would go through the function and look for any spelling errors or indexing errors. Right. The second thing that I would try is there's a line of code that I think I might have included in this one, but I might have taken it out to the scroll, which is suppress callback exceptions. So that line of code is designed to handle callback errors like this one. And I was going to say if it was missing, then that might be ridiculous, but it's not missing. It's actually that's not. The third thing where I've seen this happen is when I first built out the multi-tabbing tab, my callbacks on tabs did not function unless I placed it into the primary file. So what we're experiencing feels similar to that, and I wonder if it has to do with the placement of your callbacks. You, in fact, you have everything in a single app.
Right, so they're all in the same.
So you're not actually importing anything.
No, so I am importing this tab template, and the tab template, all of it's working with the tab. That's not the tab. So I was thinking if there was something with the typo, that's written up also.
Do you specify your default value? Value is equal to 0. Okay. Here's a troubleshooting step I would try. Try changing that to 1 and then to 2 and see if the problem moves. That might help you identify where it's going.
Okay.
But other than that, I'm not saying that. That is an interesting way to structure it. Okay, so calculating a few simple summary stats on your data frame. Last Thursday, we saw that you can describe your entire data frame by simply putting in the name of the data frame followed by the word describe, and it will list all of the numeric columns in your data frame with the count, mean, standard deviation, minimum and maximum values, and then the 25th, 50th, and 75th percentile. Describe all columns. But you can also describe a single column as prod, let's go with price. It's a simple one. Price, capitalized, not describe, list price, sorry. And it'll give you the same information over here, 504, 438, 773, 504, 438, 773. So it lists for a single column, or you can describe a subset of columns. You can probably guess where I'm going with this one. You can do prod bracket, bracket. Notice the use of the double bracket. List price, comma, and weight, comma, standard cost dot describe. And here it'll give us the count, mean, standard deviation, minimum and maximum, etc. for the 3 columns that we specified. But not only can you call a subset of columns, you can also describe a subset of these, what is that, 8 statistics. These are like the 8 most common statistics you'd want to report. So you can do prod dot mean will give you the mean value of everything in your data set. You can do prod dot median, and median and mean, median, and mode are obviously very similar. You can do prod dot min, prod dot max. You can see the naming convention is very similar to everything that's in the describe function. So up here I've got count, mean, STD for standard deviation, minimum and maximum. The only ones that are a little bit tougher are the 25th and 75th percentiles. For that you have to specify quantile, prod dot quantile 0.25 will give you the 25th percentile of that individual, of that data set. And this of course is for the entire data frame. But you could do something very similar, copying all of this and pasting into another cell a little further below for a single column. And here I simply am going to replace, using my find and replace option, I'm going to replace prod with prod list price. Replace all inside the cell, and it'll give me the same information, only I don't really want quantile here, so let's go back to 5. But for a single column, in this case, whatever the list price is. And finally, you could also do it for a subset of columns. So this time I'm going to replace list price with list price and weight. And I need the double brackets. Notice that autocomplete does not work in the find and replace box. Let's do list price and let's do weight. Replace all and run. And now we have the 50th percentile, or the median, for the list price and also the weight variable. And you could do that for a number of columns, not just two. All right, let's try renaming some columns. So what are our column names again? How do we find that out? We'll just do prod.columns. Let's suppose that we don't really like some of these names because they are extremely long. Let's take a really long one here. Weight unit measure code. We're going to abbreviate that. Prod.rename. And here I'm going to use parentheses the columns that I want to rename have to be specified as a dictionary. So I want to rename this as WUMC for short. And I run that. And it's not displaying because there's so many of these. But if I then print prod.columns, it looks like it didn't take. And the reason why is because we need to specify that we want the change to take place in place equal to true, so that it makes a permanent change to my data set. And now the column has been renamed to WUMC. But if I try to rerun that cell again, it will give me an error message because the old name no longer exists. You can't run that cell more than once without rerunning the entire Jupyter notebook.
But now this has been written to the file.
No.
Yeah.
It is that there's a file that's in my rapid access memory, but the underlying file has not been changed. Do you remember how to overwrite the file? We learned that last week. Prod.overwrite file is prod2csv, and then give it exactly the same file name. File name .csv. We'll create a new file based on the changes that I've made. Let's try changing a couple of names in one blow. Prod.rename columns are going to be equal to, let's change product ID. I'm just going to call this one ID, and then I'll change name to prod name, and then maybe I'll change product number to just number, and be sure to specify that I want the change to actually happen by saying in place equal to true. And then when I call prod.head, I see that my new names exist. ID, prod name, and number are the new column names that weren't there before. Do this with multiple columns. And let's do a few common operations with pandas. And I'll end with this, and then I'm going to turn it over to trying all of this with a new data set. Okay, so up until now we've seen prod color. But what if I want to know what those colors are? I see lots of blacks and I see lots of silvers and I see some blues and some yellows. What if I just want a list of the colors? Well, value counts will show me all of the colors in descending order. There are 93 black items, 43 silver items, but only 4 white items and 1 gray items. Now, what's missing from this list is the nans, the null values. Drop NA equal to true is the default. Drop NA equal to false will display nans as 248. So let me put these two side by side. And give it a comment here. Show all values of a categorical variable. Don't display nulls. Do display nulls. But if you try that on a continuous variable, such as list price, you'll get more than you bargained for, because there are lots and lots of values for a continuous variable, probably 500 some. So this is really only useful for categorical variables. So what was another one in here that was categorical? I think that style and class are. Let's try that. Let's try style, dot value counts. So we've got women's, men's, and unisex. But notice that right now it's sorted by the frequency. Unisex is 176, 28 women's, and only 7 men's. But what if I want to sort it by U, W, and N? I just add sort index. And now it's MUW because it's sorting alphanumerically by the index. So display frequencies sorted by the index.
What's the difference between continuous variable and categorical variable?
Continuous is a number, some number value, and a categorical has discrete units. So colors are categorical, dollars are continuous. The names of this people in the class, that's categorical, but our height or our age or the amount of money in each one of our bank accounts, those are all continuous variables because they're numeric.
Also, I had a question.
Yeah.
So the categorical variable, or what's a discrete variable is a categorical variable? Or?
Well, categorical variables, I guess I'm using the word discrete in two different ways. Numbers can be discrete, and categories can be discrete. So I think what I meant to say was not a discrete group of items, but rather a non-ordered short list of items. So think about colors, for example. Is red higher than blue? Is yellow lower than green? No, there's no order to them. And you can't say the interval from red to yellow is the same as the interval from yellow to green. That doesn't make any sense. But you can do that with numbers. 100 is higher than 50, and the interval from 50 to 100 is the same as the interval from 50 to 0. So that's what makes it continuous. But yeah, you're right. I think I misused the word discrete there.
And then the flag variables like 1 or 0.
Yeah, let me take a look at that one. It was called make flag, right?
Yeah.
Prod. Let's call that one up and see what it looks like. Make flag that value counts is 1 and 0. Yep, that's a binary.
Best practice for using 1 or 0 as opposed to boolean that or true or false?
That's a great question. So true and false, those are actually treated as 0 and 1, which is why we can do things like true plus true is 2, right? Because they are 0s and 1s. But I don't know that it's best practice. It's just customary in Python to do it this way. And one of the useful things about it is that if you take prod, make flag, and you call the mean 47, that also means that 47% of the data set is value true or value 1, which you couldn't do if you were working with booleans. Yeah, that's a great question. But going back to value, frequencies and value counts, let me get rid of these extra cells. What if I just want a list of the colors and nothing else, right? I don't really care how many times the color appears. I just want the color. Prod color dot value counts dot index. There we go. Will provide the list of colors in my data set. And what if I just want the frequencies? It's almost exactly the same code, but instead of index, call values. So now it gives me the numbers 93, 43, 38, which correspond to black, silver, red, etc. But what if I want to know how many unique colors are there? There are two ways to do this. I could have taken this code from up here and simply called its length. So the length of the list of colors is 9. Or I could have done, and this is a simpler way to do it, prod.color. N unique will also give me 9. And finally, list the unique colors. So again, there are two ways to do this. You can use this code here, which lists the unique colors, or you can simply do prod.unique without the n in front of it. Unique, you can spell that. And it gives a similar set of values, only it also includes this time the nans, or missing values. So I guess to get this truly identical, you'd want to do drop an a equal to false. And now it'll be the same either way. And we are at 8:07, so we've got 23 minutes left. Back at the beginning of this Jupyter Notebook, we listed all of the files that were in the data folder. What I'd like you to try and do is choose a different file and run it through all the same code that I did for this notebook. And I'll display that as shorthand up here. But choose one of the C's. Don't choose a text file or one of the others like a data file. But choose Ozone or choose Airlines or choose any of these CSV files. Here's one on baseball players, for example, NBA players. Try one of these, and as a summary of all of the techniques that we learned, put this up on the big screen. Here's a list of all the data frame operations that we took a look at. Right? Shape, columns, index, how to select an individual column, how to rename a column, how to describe, call value counts and unique, and how to build a filter. Well, I guess I forgot to talk about sort values, but that one is pretty easy to discover. It just sorts by any given column. So try all of these, but on a data frame of your choice. And when you have something at the very end, your final filter, go ahead and slack that out so that we all know you got to the end of it. Or just however far you got when you get to 8:30, slack out that last cell so we can see how far you got. Call me over if you have questions or troubleshooting. And I will leave this up here on the screen. So Eric's got a nice filter here on some of the baseball data, showing players who have played for more than 15 years and whose at-bats are greater than the average at-bat of players in the data set. So these would be your veteran sluggers here. Unfortunately, the data set doesn't have names. Be sure to call me over if you've got any questions or things you'd like me to clarify.